Example 4. In 2000, Littleton had a population of 10,900 people. Littleton's population increased by 600 people each year. In 2000, Tinyville had a population of 10,000 people. Tinyville's population increased by 10% each year. Part A, in what year will the populations be equal? So starting out to do this, I'm going to start with a table. And we don't have a whole lot of room here, so I'm going to really try my best. But in our table, I'm going to have year. And then I'm going to have Littleton. And then I'm going to have Tinyville, which I'm going to abbreviate as TV. Now, we're starting in year 2000. And in year 2000, I know that Littleton has a population of 10,900. And I know that Tinyville has a population of 10,000. Okay, so it looks to me like Littleton is starting with more people. Tinyville is starting with less people, but they want to know when they're going to be equal. So maybe Tinyville's eventually going to catch up to Littleton. So then I'm going to go 2001, 2002, 2003, and finally 2004. And if we need more than that, well, hopefully we don't, because my table won't go any further because I don't have that much space. Anyways, starting out, it says Littleton population increased by 600 people each year, which means if I'm going up by 600, I'm going to add 600 each year. And then thinking about that, if it's up by 600, up by 600, up by 600, I know that this is linear. So let's figure out these numbers. We're going to start with 10,900 plus 600, 11,500, plus 600, 12,100, plus 600, 12,700, and then plus 600, 13,300. Now let's go look at Tinyville. So Tinyville, it says, is going up by 10% each year. Well, 10% is also a growth, but more specifically, because it's a percentage, this is exponential growth. Now, if we're doing exponential growth, do we remember we've got like y equals a times 1 plus r to the t power? Now, specifically, what I'm looking for here is this 1 plus r, because I'm going up by 10%, 10%, 10%, 10%, but 10%, first of all, is 0.10, because 10% is 10 out of 100, so 10 divided by 100 is 0.10. But if I multiply by 0.10, I'm actually going to get a smaller number. So we need 1 plus r. So 1 plus 0.10 is actually going to give me 1.10. So here, I'm going to multiply. We're going to take 10,000 times 1.1, which gets us 11,000. Still smaller than Littleton. Multiply by 1.1 again. 12,100. Oh, look at that. It looks like it caught up. Now, just for fun, we're going to keep going. Multiply by 1.1 again. Okay, so now it's more. And then we're going to do this one more year. 14,641. Okay, and then it's getting even bigger. So in what year were the populations equal? We would say in 2002. And then in order to back up that answer, you would kind of draw an arrow, because otherwise your teacher is going to say, where did that answer come from? Part B, suppose Littleton's initial population doubled to 21,800 and maintained a constant rate of increase of 600 people per year. Did Tinyville's population still catch up to Littleton's population? Well, one way to do that would be to continue our table. And we'd have to change a couple things because they actually want us to double. Instead of 10,900, we're going to do 21,800. So if these guys start relatively close together, Tinyville is eventually going to catch up. Well, what if this guy started a lot higher? Will Tinyville catch up? In order to do this, we're going to look at it graphically. So in order to look at it graphically, I first need some equations. I'm going to start with Littleton. Now, we agreed that Littleton is linear growth because they are growing by a constant rate of increase of 600. So that means their slope is 600. Now, their y-intercept is their starting population, which we're going to double it, and we're going to start at 21,800. So linear growth, we have y equals mx plus b. So 600x plus 21,800. Okay, keep that in mind. Now, our other one we're doing is we're going to do Tinyville, TV. Tinyville, we said, was exponential growth. Okay, we kind of took some notes up here. Exponential growth, we have y equals a times 1 plus r to the t. So y equals a. Starting population of Tinyville. Well, starting population of Tinyville is 10,000 people. 1 plus r, we said, was 1.10 to the t power. Now, for the sake of graphing, I'm going to switch that over to x because the calculator we're going to use here is not going to like the variable t. Okay, now, in order to graph these, open up your Google. We're going to go to desmos.com. When you're on the home page, which will look like this, grab your graphing calculator. And the first one we're going to do is Littleton. So Littleton was 600x plus 21,800. Now, these are really big numbers, so if you're looking over here at the moment, you're not going to see anything. That's okay. Then we're also going to graph Tinyville. So 10,000 times 1.10 to the x power. Now, again, you're not going to see anything. So go over here. Do you see this little tool? We're going to change our window. On your x-axis, I want you to change this number to -20. And then I want to go up to 50. On your y-axis, I want you to change this number to 0. And I want you to change this number to 40,000. Now, let's take a look at what we're looking at. So, y-axis. The red one is your linear growth. It's making a line. And it starts at 21,800. That's your population in Littleton. And it's going up by 600 every year. Now, your blue one, that's your Tinyville, which is exponential, which starts at a population of 10,000. And then it goes up by 10%, 10%, 10%, 10%, 10%, 10% until they meet. So if you double click that point, and it looks to me like after about 10.9, so after about 11 years, Tinyville is finally going to get bigger or higher. Notice the blue line is above the red line. So Tinyville does get higher than Littleton after about 11 years. Okay, so at 10.9 years, their populations are both 28,362 people, but then Littleton keeps just going off slow, and Tinyville gets a lot higher. So let's go back. Did Tinyville's population still catch up to Littleton's? And we're going to say yes, after about 11 years. It will still catch up. Okay, part C. Suppose Littleton's rate of increase doubled to 12,000 people each year. Okay, so now we're still talking this guy over here. Except instead of being 600 people each year, we're going to go up 1,200 people each year, in addition to doubling the initial population. So the initial population is still going to be 21,800. Did Tinyville's population still catch up to Littleton's? Explain. Well, let's see. So we're going to have y equals, and this is for Littleton. Instead of going up by 600, we're going to go up by 1,200, so more. And we're still going to have a doubled starting population. Now, Tinyville, we're leaving the same. Okay? Tinyville is still going to be 10,000, going up by 10% each year. Do you think that Tinyville will still, even after this one's doubled and this is higher, do you think Tinyville will still catch up? What do you think? Let's go back to our graph. Okay, so instead of 600, we're going to double that. We're going to go up by 1,200. Take a look at your graph. Littleton, still starting at 21,800. Tinyville, still starting at 10,000. Did Tinyville catch up? And the answer is yes. Okay, but this time, instead of taking about 11 years, it took about 14 years. And if you kind of move it, then you're looking, and after about 14 years, 14.2 years, Tinyville is still higher, okay? And again, why is this happening, guys? The reason this is happening, the reason no matter how much we start in Littleton, no matter what the rate of change is in Littleton, Tinyville is exponential growth. So did Tinyville's population catch up? Yes. Okay, why? Because, that's my abbreviation for because, exponential growth eventually will outgrow linear. Okay, and that's every single time. It might take a little while, but eventually exponential growth is going to get bigger than linear.